Alright guys, graphing rationals, day 2 essentially. So these will be a little more complicated as things will cancel. Because of that canceling, we will now see some holes in the graph, potentially other types of asymptotes, and that's pretty much all that is new when compared to the previous notes. So let's get to it. So step 1, factor and simplify. Step 2, find everything we need. Asymptotes, vertical, horizontal, other. We discuss how to find vertical and horizontal. I'll show you how to find other. They come up in any examples. Find the intercepts of the simplified function. Holes in the graph. If anything canceled, if a factor canceled in your denominator, that will create a hole in the graph. And then after that, make a table. Pick some points of your choosing for more detail. It's a good idea to pick some points around your x-intercepts and vertical asymptotes. All right, so number 1. So factor if possible. The numerator is going to factor into x plus 2, x minus 2. So that's going to cancel there, resulting in x minus 2. Okay, so this function is what we are graphing. That function is exactly the same as this linear function everywhere except when x is negative 2. So if we made a table for the given function, you cannot plug in negative 2. Plug in negative 2, your denominator is 0. So it'll be undefined. If you made a table for this one, you plug in negative 2, negative 2 minus 2 is negative 4. So for this function, it is defined, but we are graphing this one. Okay, so let me erase some of this. All right, so we've simplified it. Let me go in and show you why it's undefined. So we plug in negative 2 here. You're going to get 4 minus 4, so your numerator would be 0. Negative 2 plus 2, so you get 0 over 0, which is called an indeterminate form. We'll talk about more of that later. In pre-cal, you'll see some of that. But it's undefined in either case, so that's what happens there. Everywhere else, so let's just plug in some random values. Let's see, let's plug in something that's going to work out nice. Let's plug in 4. So we'll get 16 minus 4 is 12 over 6. Plug in 4 and you get 2. I plug in 4 over here. So I'll plug in 4. I'm also going to get 2. No matter what you plug in, you're going to get the same result everywhere except when you plug in negative 2. Put that back in here. X minus 2. Let's plug in 0. 0 minus 4 is negative 4 over 2. So plug in 0, you get negative 2. Plug in 0, you get negative 2 here as well. So we can do that over and over and over again, and the tables will match. So really, we just got to graph this guy. So that's mx plus b, slope of 1, y-intercept of negative 2. Slope of 1, rise over run, rise over run. So that's the graph of this guy. But again, keep in mind, we're not graphing that. We are graphing this one here, which is undefined when x is negative 2. So what's happening there, let me find that point. So when x is negative 2, right here it's undefined. So at that point, you would leave it blank. You put a hole there. If you're drawing it by hand, just draw a little donut. If you want to find out where that donut, that hole is, well, you plug into this function. It's at negative 4. So this function has a hole at the point -2, -4. Everywhere else, you're just graphing this here, this linear function. So because of that, there are no vertical asymptotes and no horizontal asymptotes. We'll see something about oblique or skewed in a bit. That's that. Intercepts. Let's see. X-intercepts. Y-intercept. Y-intercept is at 0, -2. Right here. X-intercept set it equal to 0. That happens when x is 2. So we have our intercepts. Check. Asymptotes, check. Holes, check. Any other points, knock yourself out. Get more detail as you wish. So that one's done. We have all the characteristics. And the notes that are typed out that are with this assignment, they're using Schrady or Rady, which is just an acronym to help you locate all these key features. But that's it. I'm going to be doing it in this method. If you're curious about the other method with Rady, go ahead, look at the notes. Again, it's just an acronym to help find intercepts and all that, asymptotes and so forth. All right, number 2. So factor x plus 3, x minus 3. Cancel, so x plus 3. So let's graph x plus 3. Y-intercept of 3, slope of 1, so 1, 1, 1, 1. So there's that graph. But again, we're not graphing that one, we're graphing this one. This one, you cannot plug in 3. If you plug in 3, you would get 0 over 0 again, which is undefined. So we will have a hole in the graph when x is 3. What's the y coordinate going to be? So let's plug in here. It's going to be 6. Just plug in 3 there. 3 plus 3 is 6. So at the point 3, 6, we have a hole in the graph. So 1, 2, 3. So about right here is a hole in the graph. So make sure that's blank. Draw a little donut to determine that hole. So this function is essentially this function, x plus 3, everywhere except when x is 3. So sorry, this is x minus 3. Oh, my mistake. Let me go back. Looks like I made an error. Let me clean this up. We're left with x plus 3. 3. Oh, no, we're good, we're good. That is correct. Graph x plus 3. We cannot plug in 3 into the function. We get 0 over 0. And that will occur at the point 3, 6. And this one's done. Asymptotes, none. X-intercept, so set it equal to 0. So it occurs when x is -3. That's right there. Y-intercept, plug in 0, that occurs at 3, which we already have. And that one's done. We have all the characteristics that we need. Asymptotes, intercepts, holes if they exist. Real quick, let's talk about domain real quick. Domain of this function is to be all reals except 3, right? We cannot plug in 3 there. So that one is done. If you wish to discuss end behavior on this, when x gets really, really large, the graph, well, is x plus 3. So you would just plug in at that point. As x gets really small, you just plug in and x plus 3, that line is where the graph is ending, and it is that line. It's kind of the arbitrary case, if you will. All right, let's go to the next one. All right, 2x squared. The bottom's going to factor into x plus 3, x minus 3. Nothing cancels. Nothing cancels. So x-intercepts. Let's get our intercepts going. Y-intercept, plug in 0. What are we going to get? 0 up top, 9 on the bottom, so 0, 0. X-intercepts, that'll occur when you set it equal to 0 and solve. Step 1 would just cancel that. So again, a shortcut is just set your numerator equal to 0. So it's the same spot. All right, so something interesting is going to happen here. The 0, the x-intercept, is from this x here that is being squared, so it's an even multiplicity. When that happens, the graph's going to be tangent at that point. It's not going to cross it. It may go that way or it may go this way. We'll have to determine that in a bit. So just keep that in mind. All right. So let me clear this out. So we're graphing this guy. None of the factors on the bottom canceled. So because of that, there are there are no holes in the graph. These factors did not cancel. All right, asymptotes. Vertical asymptotes occur when your denominator is 0. So we can just solve that. So there's one of them. There's the second one. So we have two vertical asymptotes at 3 and -3. There's that guy. And that one. So x equal to -3. X equal to 3. These have multiplicity of 1, an odd one. So the graphs will approach them in opposite directions, not in the same. Either like that or the other way, and we'll determine that in a second. Horizontal asymptotes. Let's see. So the numerator has a degree of 2. Denominator also has a degree of 2. So then you take the ratio of the leading coefficients. So y equal to 2 over 1 is your horizontal asymptote. All right, let's get some key points, kind of see what's going on here. Actually, let's see if it crosses that horizontal asymptote, because I think this one is. So let's go back here. Let's set this equal to that value. Set it equal to 2. So I'm just setting it equal to this value there. Let's solve this guy. So multiply both sides by x squared minus 9. So times 2 times 2. Those cancel. We get a false statement. So it'll never cross that value. It's never equal to 2. So we're good. Let's make a table. You can fill out some key points. This is going to go here and here. I'm just rushing a little bit because I'm running out of time on this recorder. It's going to go in opposite directions because this came from a factor that had a multiplicity of 1. Similarly here, multiplicity of 1, they go in opposite directions. And it'll never ever cross it, which is what we determined here. We set it equal to that y value, and it never happens. We got a false solution at the end, so our assumption is false. All right, so we have everything: asymptotes, vertical, horizontal, intercepts, holes, and behavior. It approaches that horizontal line there, and it never crosses it, as we determined here once again. So that one's there. I'm short on time on this video, so I didn't do any more points. But if you wanted more detail, just pick values of your choosing, 4, -4, 0, and so on, and just plot them along. So that one's number 3.